So we're going to talk about transformer connections here, and now this is going to start taking the combination of all the other videos that we did. So I got to give credit where credit is due, and most of these diagrams come directly from the SEL 587 manual. So the important thing to remember when you're doing transformers is no matter whether you have a three-phase or a single phase, it doesn't matter. You can have a three-phase transformer with 3 cans on a pole, 3 single-phase cans on a pole. This is a single-phase transformer, okay? 1 core in the center, and then you have a primary winding and a secondary winding. And if you look right here, you've got more turns on the primary than you do on the secondary. This is probably something like a 2 to 1, okay? So ratio, there's no vector diagram for this because there's no phase shift. So this is the vector diagram is a 12 to 12, right? So it's a 1, or it's just a 1 to 1. There's no change, okay? 0 degree offset. So that's just remember that all transformers can be broken out into single phase transformers, okay? So let's go ahead and take a look at this. This is an example of a Y or of a DY11. Now, in that same 587 manual, what you'll see is that they're listed as a DY11. It's also called a DACY, and you need to remember to understand this is it's a DAC with a Y. Okay, and a Y is a neutral connection, so they don't have to identify. But the DAC, you could hook up the delta to the B phase coil or the C phase coil. So the way that this is outlined is when you look at A phase connection right here, it actually connects from, it's a delta and it's DAC. So it's DA minus C voltages, okay? So that's how these are supposed to be outlined. All right, and what you end up getting is an 11 clock shift. So we'll do that on the next page, but here let's just go over how to cook these up. So what I like to do first is just look at the single phase, I'm sorry, the Y side. It's always easier to start with low hanging fruit. And the Y right here, there's no neutral coming out of this transformer, so we don't have to bring the neutral out. And this is just, you bond all the negative polarities, right? And I'm just going to call the tops of these coils the positive polarities and the bottoms are the negative polarities. And then we don't have polarity dots on this, but the rest of the diagrams moving forward will. These diagrams right here have polarity dots on them. You can see them right here. And essentially, this coil is the C phase coil, and this is C phase going out. So that's the polarity dot respectively, okay? So I just put polarity dots here to make our life a little easier, but you could just imagine that they're there. But what they really do is they identify the phase shift from the primary to the secondary. Okay, so if you were looking at this in this transformer, they had a polarity dot here and a polarity dot here. If I say that on this, between these two, this is my hot and this is my neutral. If the sine wave is going up here, then on the secondary it's also going up. Okay, so that means that there's no phase. The peak is in line with the peak over here. Really, it's probably a couple minutes off of degrees, but it's almost 0 degrees offset between the two. All right, that's what the polarity dot's supposed to represent. If we flip them, then what's going to happen? Well, if we flip it over here, then what do we have? Well, what it comes out is going to be like this with respect to the primary. Okay, so that's why we identify polarity dots. And on the secondary here, it's a Y. So we just got to bring out, we're just going to assign this as A phase, B phase, and C phase cores. And so that core is respective of these, these two coils is A phase coil. So we're just going to bring out A phase right here. This is A. Actually, I'm going to make this as a little a. I need to remember that convention moving forward. And then we got, this is little b. And then this one right here is going to be little c. And there it is. Okay, that's the Y. It's pretty darn easy. So then we're going to look at the delta side. Now remember, this is a DAC transformer. So that means that our A phase coming in, well, all of our voltages going in are going to be connected to our respective polarity tap. So this is a B, and this one is going to be C. This is our respective polarity tap. So the C phase voltage going in is our C phase coil on the polarity side. That's what I meant by that. And so what's our DAC. So our A phase right here is going to connect also to the negative polarity of C. Okay, and is that correct? Well, let's look over here at this diagram that they have. A phase comes in and it also connects to the negative polarity of C and the positive polarity of A. Okay, that's what we got going on. And so you could just follow this convention moving forward. But we're going to take this one and we're going to connect it. Well, where do we connect it to? Well, the negative polarity of A connects to the positive polarity of B. That's pretty easy, right? And then the last one that we have here is the negative polarity of B connects to the positive polarity of C. And that's how you do this. Pretty easy. And this one will be a DY11, also called a DACY.